In physics, the dynamo theory proposes a mechanism by which a celestial body such as Earth or a star generates a magnetic field. The dynamo theory describes the process through which a rotating, convecting, and electrically conducting fluid can maintain a magnetic field over astronomical time scales. A dynamo is thought to be the source of the Earth's magnetic field, as well as the magnetic fields of other planets. History.
Hey everyone, my name is Kyle Lunsford, and for my demo for MAE ECE 535, I will demonstrate principles of Faraday's law and Lentz's law using a magnetic braking system where I have a conductive yet non-magnetic disc of which I will apply a magnetic field to in order to produce a braking. So here's my electromagnetic braking setup. What I have here powering the rotor is a simple 3-volt DC motor powered by 2 C-cell batteries, which is about 3 volts, run through some ugly wiring to a push button switch to spool up the rotor. And the stand and bracketry that I have here I designed in Pro E and built on a 3D printer. And I have 10 neodymium magnets, and what I'll do here is I will spool the disc up and I will apply one of these magnets to this disc, which happens to come out of a standard hard drive. And as you can see, it's not magnetic, however it is conductive. And so I'll spool the disc up here. You may be able to hear a slight roar. And I'll actually just kind of let it spin a little bit, just kind of see how it slows down on its own when there's no magnetic field applied. Still going. Alright, I'll just stop it. Then I'll spool it up again and I'll apply one magnet to the disc. And getting close enough without touching it, you can see that the disc eventually stops. And I will do it again with 2 magnets. You should notice there's a slight increase in the braking force. Notice it stopped a little bit quicker. And this time I'll apply all 10 neodymium magnets. See, it stops almost immediately as soon as I get close enough proximity to the disc. And the size, essentially, or the strength of the magnetic field applied to the disc is proportional to the braking force that is created. And this can also be considered very similar to a traditional braking setup where you actually have physical contact pads to the rotor, where the larger the surface area, the stronger the braking force. And there's kind of a similar phenomenon here. The more magnets you apply to the disc, the stronger the braking force. Alright, what I've just demonstrated with electromagnetic braking, Faraday's law basically states that the motion of a conductive material in the presence of a magnetic field creates eddy currents within the material. And this, in turn, creates an opposing force to the direction of motion, and that is stated by Lentz's law.